Siri, pick a number between 10 and 20.
It's 11.
It's 11. Jeez. Lightweight. One, two. That's it.
11. It's a lot harder than it looks. Alright, so today we're looking at section 4-4b. We're still looking at the properties of logarithms, but a few different properties that you will be using in the next couple of lessons. But make sure you guys pay attention to this because this will be used a lot for the next few lectures. Our first one is going to be what happens if I take a logarithm and that logarithm has a power. So for example, let's say I had something like this. Log base 2 of 4, and the 4 is actually cubed. So I have a power of 3 here. Okay. So how are we going to deal with a logarithm with an exponent? That's what we're looking at. Well, let's look at the easiest case of this. This is going to be called the inverse properties of logarithms and exponents. And this is where the base, so if I take log base 2, if the base is the same as the number I'm taking the log of. So if those two numbers are the same, let's say it's raised to the power of, just throw it out there, 4, well, this logarithm, the bases, I call it, let's refer to this as double B, because there's those two numbers there are the same. Well, they just cancel each other out. And this will be equal to this exponent here. So that will be equal to 4. That's what that log equals. And so you see here, the bases are the same. They cancel out, and I'm left with 7. So like I said, this is probably the easiest one to do, because you just really cancel them out. This one here, I take a number, let's say 2 raised to the power. Now the exponent in this case is our logarithm. So it's 2 raised to a logarithm. 2 raised to the power of log base 2 of, let's just say, 4. Well, what does this equal? Well, now here's my double B. Right there and right there. They cancel each other out. I'm left with 4. So that's what this logarithm would be equal to. So if you ever see repeating numbers, check if they're the base and the number we're taking the log of, or that number and this number here, because if they are, they cancel each other out, and I'm left with the exponent, or that one right there. So let's do a few examples. Our first example here, example A, let's say I took log base 8 of 8 raised to the 3x plus 1. What does this equal? Well, this logarithm, my bases, or the 8's cancel out. I'm left with that. And that's it. Super simple. Example B, let's say I took log base 5 of 125. And I see that I don't have an exponent here, but can I rewrite this? So I'm going to actually change this. I write this as log base 5 of 5 cubed, because 5 to the power of 3 is 125. So I can rewrite this, and now notice the repeating 5's here, which means they cancel each other out, and I'm left with that. So this logarithm will be equal to 3. Now you could have recycled this, could have gone this route too. Could have taken log base 5 of 125, set it equal to x, and then recycle. and get 5 to the x equals 125 and solved. That would have been perfectly fine to get 3 that way as well. But the double B, this method here, that's just another way to solve this. So you see that there's going to be a lot of different ways to solve these. It's really up to you which makes the most sense or whatever is the easiest. But both methods in this case work. Let's do one more. Example C. 2 raised to the logarithm, raised to the power of log base 2 of 27. Here's the repeating numbers, 2 and 2, those cancel out, and I'm left with 27. So that's what this logarithm will be equal to. So all that gets canceled, I'm left with 27. And that's when you see the repeating numbers here. Alright, so that's the easiest one we'll be looking at today. Our next one is really important though, and this is, we're going to refer to this as plogging, or plog. So whenever I say let's plog this, I'm referring to this table, this property here, the power property of logarithms. So the power property of logarithms, or plogging, what this is where you take a logarithm, base b of a, raised to a power, whatever number that is, raised to p, and I'm going to take the power, I'm actually going to move it to the front and multiply. So this becomes p times log base b of a. So this is a way to get rid of this exponent here, move it to the front, and notice that it spells plog, so that's why we call it plogging. You move it to the front, and now you take that exponent, and now we're multiplying, and I can solve the logarithm and then multiply it to the exponent. So it simplifies things to solve. So let's do a few examples of this, and again, this is important because we will use this quite often. So our first example, let's take log base 3 of 81 squared. Alright. So to solve this one, I could try to write it as double base. I could try a few different methods, but we'll see that the easiest way to solve this is just to plug it. So I'm going to rewrite this, take the exponent, move it to the front. So 2 times log base 3 of 81. So that's my first step. That's step 1. Now step 2, I'm going to solve this logarithm. But we can't forget about the 2 here. So I'm 2 times whatever this logarithm is solved as. So I take log base 3 of 81, set it equal to x, let's recycle. So 3 to the power of x equals 81. Well, that is going to give me x equals 4. So this logarithm, this one here, that is equal to 4. So I'm not done yet, so all I'm going to do is take that logarithm, and since it's equal to 4, I'll do 4 times 2, and I'll get 8. And that is my answer right here. So my solution, I could just write it as 8, or if you wanted to write the whole thing, you could say log base 3 of 81 squared. That will be equal to 8. That's what it's evaluated as. But again, this is okay if you stop here. A few mistakes I see people make is that after they plug it, after they move the 2 to the front, they forget about it. They just drop it off and never come back to it. So you can't forget about the 2. You have to carry it down, solve the logarithm here. After you solve the logarithm, then multiply them together, which gives you the answer. Alright, let's do another example of this. Let's take example B. Let's take log base 5 of 1/5 raised to the power of 3. So what is that equal to? Well, step 1, I'm going to plug it, so move the 3 to the front. So 3 times log base 5 of 1/5. Now, don't forget about the 3 times whatever this logarithm is evaluated as. So let's go ahead and solve that on its own. Log base 5 of 1/5, let's set it equal to x. I recycle. 5 to the power of x is equal to 1/5, so I have to flip the 5 to the bottom. Hopefully you guys remember a negative exponent does that. I'm not changing the number, it's just flipping it to the bottom. So that's x is a -1. So after I solve for the logarithm, I take that and I plug it back in and multiply it by the 3. So this logarithm would be equal to -3. And that's my answer. Now I'd suggest always check for the double B. Because if you can use the double B, then it's a lot easier to do it that way. But you can always plug it too. And you can reverse a plug too. Sometimes that might be helpful. So let's say I had 2 times log base 2 of 8. Just throw it out there. Sometimes you might want to reverse the plug and put it up here. You can also do that. I'm trying to think of a quick example as to why you would do that. Yeah, just sometimes just keep that in the back of your head. Sometimes you might have to reverse it. You'll see on the homework sometimes that it's easier to solve. Alright, so here's a few examples for you guys to try on your own. I suggest pausing the video once I write these and attempting them. So first one is log. Now remember, no base is written, so it's a common logarithm. It's assumed 10. So log base 10 of 10 raised to the power of 4. Number 2, we have log base 5 of 25 squared. Number 3, we have log 10 raised to the 0.9. Then number 4, we have 2 raised to log base 2 of 8x. Alright, so go ahead and pause the video and try to solve those on your own. Evaluate these logarithms. Alright, assuming that you guys pause the video, our first one, remember the common logarithm, we have a base of 10, imaginary, well, it's not imaginary, it's just an assumed base of 10. So we have double B right there, they cancel out, and I'm left with 4. That's my answer for the first one. Number 2, there's a few ways I could do this. I'm going to do it the easy way first. I could rewrite this as log base 5 of, I know 5 squared is 25, so 2 times 2, to multiply the exponents together. So this would give me log base 5 of 5 to the power 4. There's my double base, double B, and I get 4. So that's the maybe easy way to do it, but I could also plug this. I could also move the 2 to the front. 2 times log base 5 of 25. I solve the logarithm, this here. That would give me 5 to the x is equal to 25. Obviously that's 2, which gives me 4. So I get the same solution, just using a different method. Our next one, again, you see the common logarithm, base of 10, they cancel out, I get 0.9. This one here, it's 2 raised to the power of a logarithm, but I can still use double B, those cancel out, and I'm left with 8x. So hopefully you guys see how simple a lot of these are, the concepts at least. We will get into more difficult problems later on, but make sure you guys understand these base concepts. All right, last thing. Let's say you had a question like this. Log base 4 of 8. So let's say that I wanted to recycle this. Set it equal to x. I recycle. 4x equals 8. Well, 4 to what power is equal to 8? Well, that's going to be a decimal number. It's not a whole number. So this would be really hard to figure out just using our mental math. So how would I do this? Well, we can change the base if we want to. So if I take log base 4 of 8, what you can do is rewrite this as log base. You can change the base to whatever you want. I'm just going to keep it as a common logarithm, or a base of 10, over log base 10 of 4. So notice that when you do this, that number goes on top, and the base here, that goes to the bottom. But it moves up and it becomes the number you're actually taking the log of. And then the base, you can change that to whatever you want. In this example here, they changed it to 2. The reason they changed it to 2 is because 2 cubed is 8, so that would be 3, and 2 squared is 4, so that would be 2. So you get 1.5. That'd be changing, you could do this method to change it to numbers that you can easily solve using mental math. But the reason I prefer to change it to 10, or a common logarithm, is because you can use your calculator to solve these. So using our calculator to solve this, you take log base, and this is just a picture, I can actually use it. I'll show you guys what to do. So log base 10, I'm just going to write it as a common logarithm. So I rewrite this as log of 8 over log of 4. Notice that that goes to the top, that goes to the bottom. Now on your calculator, you can change the base to whatever number you want. I'll show you guys how to do that later on. But let's just learn how to use the logarithm button right here. So the log button on your calculator, that's right now in base 10. Again, you can change that. The base is 10. You can change it later. But let's just focus on using that. So all you have to do is just hit you just have to hit let's solve for the top first. So all I do is hit log and then 8. So once I hit log 8, that is going to give me, that's 0.903089987. I'm just going to round to the nearest thousandth. So you get 0.903. That's what that gives me this. And now let's go and solve for log of 4. So I'll be dividing by log. You hit log of 4, and that's going to give you 0.602. And then I do, so log of 4 gives me this. And I divide these two numbers, and that is going to give me 1.5. And that's your answer. Now you could also go log of 8 and then divided by log of 4. But make sure you're using the parentheses when necessary. If you do, just don't mess up the order of operations. Let's do a couple more. Let's say example A, I wanted to solve log base 9 of 27. Now, using our calculator, I could rewrite this as log base 10 of 27 over log base 10 of 9. Now, don't make the mistake, don't divide these. I see that mistake often. They'll reduce that and then solve it as a single logarithm. Don't make that mistake. You actually have to solve this logarithm and then solve the bottom. So when you do this, now I'm just going to do log of 27 and then divide it by log of 9. So I'm going to enter all this into my calculator at once, but I'm still solving each logarithm individually and dividing the top by the bottom. So this will give me, let's see, log 27 divided by log of 9. That's going to give you it will give you 1.5. Now one thing you have to be really careful of when you enter this into your calculator, it'll look like this. So on your screen here, it'll say log parenthesis 27. Make sure you close the parenthesis. That's really important to close the parenthesis. And then if you're doing this all in one operation, and then divide it by log of 9 and then close parenthesis again. So really make sure you're using the parentheses. If you go like this, log 27 divided by log of 9, you're going to get actually 1.45, which is incorrect, and that's because it's doing the logarithm of 27 divided by the logarithm. So the order of operations is thrown off. You really have to make sure you use your parentheses to do the top divided by the bottom. So that's an easy mistake that you can easily avoid. Let's do another one. Let's say that we had log base 8 of 16. So I'm going to change this to log of 16 over log of 8. So in my calculator, you're going to punch in log, so hit your log button, and then I'll give parenthesis 16 close parenthesis divided by log of 8. So you hit this button, and then 16 close parenthesis, that'll take care of the top, and then log of 8 close parenthesis. Well, that is going to give you log of 16 divided by log of 8. Oops, just a second. Log of 16 divided by log of 8. It's going to give you 1.33 repeating. So that's how I'd solve that question. So super easy to change the base to whatever you want, and again you could change that to, so if I go back to this question, log base 9 of 27, I could also change that to log base 3 of 27, change the base to a 3, and then divide that by log base 3 of 9. Whatever you change the base to, make sure you have to have the same for both the top and the bottom. And the reason I chose 3 is because you see that both of these numbers, you can write 3 raised to the power to equal 27, and 3 squared is 9. So that'll give you 3 cubed is 27, and then 3 squared, so 3 squared is 9. And that's what you would get there. Alright, so that's all for the lecture today. We just looked at how to use our calculator, change the base, and then use your calculator. Or change the base to solve it easily using mental math. We learned how to plug. This one's important. Make sure you know this one. And then we also looked at our double B. That one's pretty useful when it's applicable. Alright, that's it. Email me if you guys have questions. Have a good day.